So in today's lesson, I'm going to start first with recalling few things which we did in previous lessons, and then I'm going to solve trig equations. We will be doing a simple solving of trig equations in this lesson, and there will be a follow-up lesson where we'll be doing a little challenging trigonometric equations. So to start with, first of all, I would like you to make sure that you remember this table, and you need to know these values by heart. So for at least for 0, 30 degree, 45 degree, 60 degree and 90 degree, the values of sine theta, cos theta and tan theta. And there was an easier way to remember that. So you can go back to the previous unit where I did this table and make sure that you know this table by heart. And the another thing which I want you to know is that your theta, this is the first quadrant. We are going to call it as like theta, which is an acute angle between 0 to 90 degree. The second quadrant we are going to call as 180 minus theta, and the third quadrant 180 plus theta, and the fourth quadrant as 360 minus theta or negative theta. So the reason why I'm calling them as 180 minus theta, 180 plus theta or 360 minus theta, as you know, 180 is 90 times 2, and then 360 is 90 times 4. So these are the even multiples of 90, as I explained in previous video also, even multiples of 90. And when this is the case, then your sine 180 minus theta, the sign remains sine. Theta in this case, the sign here, positive or negative, depends on in which quadrant the angle 180 minus theta is. In this case, 180 minus theta is in second quadrant, and we know sine theta is positive in second quadrant. And I'm going to just recall very quickly ASTC, and the easier way to remember this is add sugar to coffee. And A means all trig ratios are positive, and remember we are going to mainly work with sine, cos and tan. Only 3 trig ratios, and then so all 3 trig ratios are positive in first quadrant, and second quadrant is sine positive, and in third quadrant tan is positive, and fourth quadrant cos is positive. So this is again another important thing which you need to make sure that you remember it. So I'm going to do a few questions, which is again, as I said, is the recall of what you already know. So first of all, if I have to find sine 240 degree, and obviously these questions we are doing it without using GDC. So how do I find sine 240 degree? So the first thing which you should do is that you change 240 degree in terms of 180 or 360. And when we are changing this in using 180 or 360 only, even multiples of 90, but we have to somehow use these common values. So if I decide to change this in using 360, that 360 minus 120, but 120 is not in this table. So I'm not going to use 360 here. So I'm going to use sine 180 plus 60 degree. So now I know that 60 degree value from this table, and I know sine 180 plus 60, which means it's in the third quadrant. And in third quadrant, this must be negative. So which means this is same as minus sine 60 degree. And now if I go back, sine 60 is negative. Sine 60 is square root of 3 over 2, so which means this will be equal to negative square root of 3 over 2. So I'm going to show you using calculator also if I got the right value or not. So I'm going to press on sine of, so I need sine of 240 degree, and make sure your mode is on degree. And then I got minus 0.866, and I'm going to substitute here alpha y, and then negative square root of 3 and divide by 2. So just to see that we got the same value. So this is all good. So sine 240 is negative square root of 3 over 2. I'm sure that, you know, there are people like who got this completely, but I felt like it's important to review one more time. So cos 315 degree. Now again, I don't want to use 180 here, because 180 plus whatever is left is not going to be in this table. So what I have to do is I have to change this into 360 minus 45 degree. Now I can see that 360 minus 45 degree here means it's in the fourth quadrant. And so you have to find out first in which quadrant your angle is going to be. Here it was in third quadrant, and we knew that sine was negative. Here cos is positive in fourth quadrant. As you know, here cos is positive, which means this is going to be cos of 45, and cos of 45 as from the table is 1 over square root of 2. So cos 315 is also 1 over square root of 2. I'm going to do another one with tan 135. Again, you have to write this as 180 minus 45, and tan 180 minus 45, as you can see, is in the second quadrant, and second quadrant means it's going to be negative, so minus tan 45, and tan 45 is 1, so the answer for this one will be negative 1. I hope this is clear. So this is how you find any of the values. Obviously, the angles which is given here, 240, 315, 135, after changing it, result into the common angles which we have in the table, but this may not be the case, and if this is not the case, then you have to use calculator, but these questions are without calculator. So I hope this is clear, and feel free to do more practice. You can find tons of these kind of questions on internet also, and in your homework also I'm going to give you few more, so that you will have a practice of these kind of things. So then I'm going to move to the next one, and the next is that the next part is, how do I find if I have sine theta is equal to, let's say, 3 over 5, and then we need to, without using GDC again, so note down, without using GDC, I have to find the value of cos theta and tan theta. So this is the question, and this question is slightly different than the previous one also. I mean, in previous one we were finding the sine of an angle, but here the sine theta is given and we have to find cos and tan here. And if you look at this 3 over 5, it's not the value which you can see in this table. So this is not, you don't see any 3 over 5 here. So how do I solve these kind of questions where they are not asking me to find theta, but they are asking me to find cos theta and tan theta? So there are two ways to do this. One way is you can use Pythagoras Theorem, so you can use that, and then the another one you can also do using add sugar to coffee. So I'm going to first show you how to use Pythagoras Theorem here. And before we do that, because here they ask you to find the value of cos theta and tan theta, and they specified in 90 degrees to 180 degree. So the domain, this is the domain for theta, and this plays a very, very important role in these kind of questions. So whenever the statement is given, you always have to pay attention to the domain which is given in the question. Underline it, highlight it, so that you know that this is the domain where you are finding, trying to find the values of whatever they are asking in the question. So I will talk a little more about the domain when I'm going to move to solving trig equations, and then I will do graphically as well as algebraically. So I will talk about this thing in more depth there. So now I'm going to show you how can I use the Pythagoras Theorem. Now I know sine theta is 3 over 5, and 90 to 180 degree, note down, this means it's in second quadrant. This is very, very important that you recognize in which quadrant they are talking about. And the another important information I'm going to draw from here is, if it's in second quadrant, I know that cos theta is negative and tan theta is also going to be negative, because remember, in second quadrant, sine is the only out of these three, sine, cos, tan, sine is the only one which is a positive. So I know cos theta is negative, tan theta is negative. So I'm going to, sine theta is 3 over 5, it is in the second quadrant. You can draw in this right angle triangle in the second quadrant if you want, or it doesn't matter. So if you have theta here, and we know sine theta is equal to, if I use SOHCAHTOA, then I know that sine theta is opposite over hypotenuse, which means this is 3, this is 5, and using Pythagoras Theorem, that's why I said using Pythagoras Theorem and actually SOHCAHTOA. So this is equal to 4. I don't think I need to show that step. And then you can find cos theta. And obviously, if it's in second quadrant, this is going to be negative 4. Okay, but cos theta is going to be adjacent, which is your 4 here, divide by hypotenuse, which is 5, and actually it's negative 4 over 5. And then similarly, your tan theta is going to be, and if you look at tan theta, it is equal to opposite, which is 3, and then adjacent. So this is going to be negative 3 over 4. So this is how you find using Pythagoras theorem and SOHCAHTOA. So it doesn't matter which method you use. The domain is important. You identify in which quadrant we are talking about, and in that quadrant which one is positive or negative. Now I'm going to show you the another way of doing this. So if you have sine theta is equal to 3 over 5, and I need to find cos theta and tan theta. So this is actually similar to like what I did it. So in this case, what I'm going to do here is I can use the trig identity. So sine square theta plus cos square theta is equal to 1. So this one I'm using trig identity to do that. Again, it doesn't matter which method you use. So sine square theta, which means this is 9 over 25, plus cos square theta is equal to 1. So cos square theta is 1 over 1 minus 9 over 25. So 16 over 25. And then you get cos theta, remember, if it's quadratic. And then there are two values, two answers. But now here, as I know that it has to be in second quadrant, so cos theta is equal to 4 over 5 is rejected. Why it is rejected? Because of the second quadrant, and we know cos theta is a negative in second quadrant. So cos theta is equal to negative 4 over 5 is what you will get here. So once you have sine theta and cos theta, because sine theta was already given, so I can also use another trig identity, which is tan theta is equal to sine theta over cos theta. So then this becomes 3 over 4, negative 4 over 5. As you know, when the denominators are same, we cancel them out. So that means tan theta is equal to negative 3 over 4. So you exactly got the same answer. Now it's up to you which method do you want to use. I prefer to use the Pythagoras theorem because as you can see that it's much shorter as compared to this one. But as I said, again, it doesn't matter. So this is what... this one. I'm going to do a few more questions here. So tan theta is equal to 5 over square root of 11, and now it's given 90 to theta to 270 degree, and you have to find sine theta and cos theta. Now again, I will again recommend you to add sugar to coffee, and then you can, in this case, you can use the trig identities, but since we only know, or we are using only sine square theta plus cos square theta is equal to 1, as you know, I'm not going to do much more on remaining three trig identity trig ratios, secant, cosecant, cot. So that's why I'm not going to approach this using trig identity. So I'll use it using Pythagoras theorem and SOHCAHTOA. So now I have to find sine and cos. So 90 to 270 means that we are talking about second and third quadrant. And now in this case, you can see from here, tan theta is 5 over square root of 11, which is positive. And out of second and third quadrant, tan is positive in third quadrant, which means we have to find the value of sine and cos in third quadrant as well. So now let's start with, now I know I'm not going to draw this diagram in the third quadrant. You can go and of course you can do that, but I'm not going to. And you know sine theta is negative and cos theta is negative, so you can even draw your right angle triangle like this, but it doesn't matter, as I said. So here, if it's theta, we know TOA is opposite over adjacent, so this is 5, this is this, and to find this one using Pythagoras theorem, this is 25 plus 11, so that is going to be 6. So sine theta is going to be, sine theta is opposite over hypotenuse, so that will be negative 5 over 6, and then cos theta is going to be adjacent over hypotenuse, so that's again negative 11 over 6. So that's your sine theta and cos theta. Okay, so I hope this is clear, because you will have a few questions, follow-up questions in your homework as well on these. So I'm going to move to the next one, next step, where I'm going to start solving trig equations. So solving trig equations. As I mentioned before, I'm going to do the simple cases first. So let's say if I want to do sine x is equal to 1 over 2. First of all, I want to emphasize on, so whenever you are solving any trig equations, you can have infinitely many solutions. Now, what does that mean? Infinitely many solutions. When you are solving a linear equation, for example, x plus 2 is equal to 3, you have only one solution, as you know. And if you have x squared minus 5x plus 6 is equal to 0, the maximum solutions you can have 2. So it depends, number of solution depends on the degree. Here, when you have a trig equation and you have sine x is equal to half, you can have infinitely many solutions. So I'm going to show you what does that mean. So I know that the graph of sine looks like this. One complete revolution. So this is 0, this is 90, this is 180, this is 270 and 360. But if I extend it and then I keep on getting this like here, and I can even extend it in this direction because of the period. So if I draw sine x is equal to half, sine x is like y is equal to half, and y is this, and we know the maximum is 1 and minimum is -1. So sine x is equal to half, y is equal to half will be this line. So this line. So y is equal to half this line. So if I just take the domain from 0 to 360, if I restricted my domain to 0 to 360, then from here to here, you can see how many solutions I'm going to have here. So for 0 to 360, I will have a solution here, and then here, and then so if it's sine x is 1 over 2, and if we have there, so it's number of solution will depend on, so number of solutions will depend on the domain given in the question. So you always have to pay attention to the domain which is given in the question. So if I am only having sine x is equal to half, then because 360 will actually stop here. So 360 is here, and then you can see here you have 1 and 2. So 2 solutions if I restrict this domain to 360, because this intersection is after 360. And if I increase this, let's say to 720, then you can see 1, 2, 3, and 4, because then you will have this intersection will go after 720. So the number of solution will depend on the domain. So domain plays a very, very important role. So I'm going to do, so this is how you can do using graphs. Again, I'm doing the simple one when the values are corresponding to the values which you see in a table. So, first I'm going to do that, and then maybe, we can also do few problems on next video, do few problems when the angle, the value is not from one of the values which you see in the table, but then you need to use the calculator. Right now in today's lesson, I'm doing everything which you can do without using calculator. So sine x is equal to half. Now I'm going to do the another way of solving it, and that is algebraical way. So algebraically, how can I solve this? So sine x is equal to half in between 0 to 360 degree. So how many solutions? I already showed you that using the graph. So there will be 2 solutions here. And also doing algebraically, we know that this is very, very important. Add sugar to coffee. And here you can see that sine x, when I see the equation, what do I see? I see sine x is equal to half. I see sine x is positive. So I see positive value of sine, and this is very, very important. So positive value of sine means the answer which we are going to get is going to be in the first quadrant and second quadrant. So what you have to do here is, when you have sine x is equal to half, using the table values, as I said, you need to memorize it. You look at where the sine is equal to half, and you can see from the table that it's 30 degree. Again, you should memorize the value. So sine 30 is half, so which means we got the first acute angle which is in the first quadrant, 30 degree, and then second one, as we know, the second quadrant, we call it as 180 minus theta. So that means the second value you will have is 150 degrees. So the answer will be 30 degree and 150 degree will be the answer for these are the 2 solutions here. Next I'm going to do is cos x is equal to square root of 2 over 2 and then 0 to 720 degree. 0 to 720 degree means 2 complete revolutions here. Now here again, if you look at square root of 2 over 2 is when x is 45 degree, the acute angle, but that's not all. So what are we going to do here is, the first value is cos is positive. I see cos x is positive, which means it's going to be in first and fourth quadrant. And in first quadrant, the value will be 45 degree. In fourth quadrant, it's going to be 360 minus 45. So the answer which you get here, let's subtract, is equal to 360 minus 45, and you got 315 degree here. So 315 degree, and then you will have another value which is going to be, you keep on adding, so what should be the next value and the next value? So you can figure that out so that we have all the values taken in 0 to 720 degree. Okay, so and remember the period of sine theta and cos theta is 360 degree, and the period of tan is equal to 180 degrees. So a complete revolution in 360 degree, and it's a and this one is 180 degrees. So 45 plus 360, 405 should give you the another value. Let's have a look. So if I do cos 405, then I will get 0.707, and then if I do 1 divide by square root of 2, do I get the same value? Yes. So 405. And how did I find this value? I added simply 360 to 405 degree. So to find the another one, if I add 315 plus 360, what I get, and then if I do cos of 675, what will be the value? It's the same value. So the next value here will be 675 degree, again by adding 360 degree to this one. So these are the values which I will get for cos x is equal to square root of 2 between this domain. So number of solution will depend on the domain. In this case, we have 4. In the previous one, when we had sin x is equal to half, and the domain was only 0 to 360 degree, the solutions we got were 2. Okay, so the next one, I'm going to do is, if you have tan x plus square root of 3 is equal to 0, and then you have to do 0 less than x less than 360 degree. I'm going to do between these two. And now again here, you can see that this is slightly different than the previous one. And now I'm going to talk about what is so different here. So if you look at tan x, which is equal to negative square root of 3. In the previous examples where I did sine, cos, and even tan, I think, the thing was here, there the values were positive. So you got sine x is equal to half or cos x is equal to square root of 2 over 2. Both of them were the example with the positive values. But here you have tan x is negative square root of 3. So how do I work with if we have negative value here? So I have my own way of doing it. It's not the only way to do these problems. You know, if you already know how to solve it, or if you studied it already, then you can stay with your method, or if not, then you can use my method as well. So I'm going to do the way I do that. So add sugar to coffee, this is very, very important. Theta 180 minus theta, 180 plus theta, and then 360 minus theta. So whenever I have a negative value, I just step number 1 I do is I ignore the sign for the time being. Ignore the sign for the time being. I'm just going to write down like that, and I will encourage you to actually take notes in your notebook as well. So ignore the sign for the time being, which means what? So I'm going to look at tan x is equal to square root of 3. What is the acute angle when I have tan x is equal to square root of 3? Again, I really hope that you memorize those values. So I'm going to bring the table here, and then you can see tan theta is square root of 3 when theta is 60 degree. So I know the acute angle is 60 degree here. But this is not the answer because we have tan x is equal to negative square root of 3. So remember that. Now, tan is negative. In which quadrant tan is negative here? It is negative in second and fourth quadrant. So I'm going to, so second quadrant is 180 minus theta and fourth quadrant is 360 minus theta. And this is theta. This is the acute angle which you got when you ignored the sign. So answer is not going to be 60 because tan is positive in first quadrant. So that's going to be wrong. So 180 minus theta, 180 minus 60, which is equal to 120. And then 360 minus 60, which is going to be equal to 300 degree. So that is your answers for between the domain 0 to 360, which means 2 solutions. So tan is negative out of like one complete revolution, it will be negative twice. Now I'm going to just check it. So tan 120, so I'm going to just do it. Tan 120 is equal to this, and then I am going to check tan 300 is equal to negative 1.732, and square root of 3 is 1.732 approximately. So that means we are correct. So again, I hope that this is clear. And as I said, the follow-up on this is also going to be, I try to like have the homework which is exactly similar to this one. Let me do another example with the negative number. So let me make my own example here. This is very but simple. So let's say that sine x is equal to negative cos x. Now, when you have sine x is equal to negative x cos x, it looks slightly different than what we had here, but it's kind of very similar. Why is this so? Because I can move cos x, and then this is negative 1, and which is tan x is equal to negative 1. Now the question is very similar to what we have in the beginning. And what is the domain here? So domain is, let's say 0 to x to 720 degree now. So we will have more than 2 solutions here because I'm talking about more revolutions here. And you know that for tan x the period is 180, and if you go back here also 120 plus 180 gives you 300 degree. So this is the another way of kind of like, you know, finding solutions here. So tan x is negative 1. Step number 1, as I said before, ignore the sign for the time being. So when you ignore the sign, what do you get here? So you get here tan x is negative 1, which is corresponding to 45 degree. But this is not the value, as I said. It's just an acute angle which we found. Tan x is negative in second and fourth quadrant, very similar to what we did before. And then in second quadrant, we had 180 minus 45, and then fourth quadrant 360 minus 45. So this gives me 315, and 180 minus 45 gives me 135. And now again you can, let's check it first. So I'm going to check this. So tan 135 is negative 1. That's what we were looking for. Tan 315, so let me look at 315 is negative 1 again. So this is exactly same. And notice 135 plus 180 gives you 315. So next value will be 180. You add again another 180, 495. And you keep on adding 180 until you are in the domain which is given. So 495 plus 180, and we'll check it, 675. And if I go again, you can see if I add 180 again, it's going to be beyond the domain which is given. And I'm just going to check tan of 495 here. So if I enter, that gives me negative 1, so I'm good to go here. And then I want to check for 675, and that is also negative 1. So these are the 4 answers which you got for this one. Okay, I hope it is clear, and you will take my advice to memorize the table and also this information. This is very, very important when it comes to solving trig equations. So in the next lesson, I'm going to do a little more complex problems of solving trigonometric equations. And your homework will be a worksheet which consists of similar questions which we covered in today's lesson.